Kusangpo, welcome to Bhutan e-learning project. This is a science lesson for Key Stage 3, classes 7 and 8. My name is Funsu Chotin. In the lower classes, you have learned this, and I'm sure you did this experiment also. If you take a container of water and put this wooden block, then you notice that the wooden block floats on water. Whereas if you take an iron nail and put it in the water, then the iron nail sinks in the water. Likewise, if you take water and oil in a container like this, then the oil and water separates into two different layers. So, like I said, in the lower classes, you have learned about floating and sinking. And you have also learned that light objects float on water, heavy objects sink in the water. But today we're going to see, why does this wooden block float on the water? Why does the iron nail sink in the water? And why, when you mix oil and water, you get two different layers, oil on the top and water at the bottom. Okay, so all these questions, the questions that I've asked here, will be answered if you know the concept of density and relative density. So I'm sure you have guessed today's lesson. So today's lesson is on density and relative density. Now, to begin with, I have here two same size baskets. So for now, you can assume that the volume of these two baskets are same. So keeping the volume constant, in the second basket here, I will put 6 balls, and the rest of the ball goes into the first basket. So what do you notice is now, in the first basket, you have more number of balls compared to the second basket, which means that the amount of substance which is contained in this volume is more than this volume. So, can you guess from these two objects which one is denser? Right. The first basket is denser because it has more amount of substance in same volume, which brings us to the definition of density as the amount of substance in a particular volume. So mathematically, density can be written as mass per unit volume. Density is denoted by rho, mass is m, volume is v. So this is the mathematical expression to find density. Density is mass per unit volume. Now, if you measure the mass in kilogram and volume in cubic meter, then we get the unit for density as kilogram per cubic meter, and this is the SI unit for density. Likewise, if you measure the mass in gram and volume in cubic centimeter, then we get the unit as gram per cubic centimeter, which is the CGS unit for density. So SI unit of density is kilogram per cubic meter, and CGS unit for density is gram per cubic centimeter. First, we learn the concept, then we write down the definition. From the definition, we write down the formula. Then we know the units, both SI unit as well as CGS unit. Now what are we going to do is we're going to apply all these things that we have learned and solve a numerical question. Usually students find problem in solving the numerical question, but the truth is if you understand the question, it's really fun. So today I'll show you how to solve a numerical question on density. So if you look here on the board, a cube of copper has a volume of 16.7 cubic centimeter and a mass of 150 gram. What is its density? So when you read this question, very important, you must know what are the keywords. So here I see 3 keywords. The first keyword is volume, then I see mass, and finally density. So you have density, mass and volume. Now you already know the relation. Density is mass per unit volume, right? So plug in the values now. What is the value for mass? Mass is 150 gram. And what is the volume? The volume is 16.7 cubic centimeter. So 150 divided by 16.7 will give you the answer as 8.98 gram. Centimeter cube is in the denominator. When you take it up, it becomes per cubic centimeter. So this is the density. How much? 8.98 gram per cubic centimeter is the density of a cube of copper. Now, after getting the density, you can just think, will this copper sink in water or float in water? If you take a cube of copper or just a piece of copper and put it in the water, do you think it will float or sink? We know because copper is heavy, so it will sink. But today you will learn why does the copper sink. The copper sinks because the density of copper is 8.98 gram per cubic centimeter. Okay, and we are immersing this copper in water. And you must remember that the density of water is equal to 1 gram per cubic centimeter, in which case you learn here that copper's density, let me write here, density of copper is greater than density of water. How greater is it? Density of copper we found is 8.98 gram per cubic centimeter. Density of water is just 1 gram per cubic centimeter. So do you see here? Density of copper is much greater than the density of water. So this is the reason why copper or any heavy object sink in the water. Okay, so in the beginning of this lesson we talked about floating and sinking, and then we said that the wood floats. Now today, if you see on the board there, I've written down the density of wood as 0.63 gram per cubic centimeter. Now for your information, this is a pine wood and the density of pine wood ranges from 0.35 to 0.85 gram per cubic centimeter. So I've just taken the average value as 0.63. And we are immersing this wood in water, and the density of water is 1 gram per cubic centimeter, in which case you notice that the density of wood is lesser than the density of water. that's the reason why the wood floats on water. Coming to the iron nail sinks in water because the density of iron nail is 7.8 gram per cubic centimeter, which is much higher than the density of water. So that's the reason why the iron nail sinks in water. Likewise, the density of cooking oil is 0.93, again lesser than the density of water. Again, this is the reason why the oil floats on water. So, students, from today's lesson, you should know that any object that floats on water will have density lesser than water, and any object that sinks in water will have its density greater than water. So this density, it is density which decides whether an object is going to float or sink. Now we are going to look at the factors that affect density. In other words, density depends on two factors. The first factor is mass of an object, and the second factor is volume of the object. Now you must be wondering, where did I bring these factors from? You remember the formula of density? Density is mass per unit volume. So see, this is the first factor and this is the second factor. Now how is density related to mass? Do you notice that here density, mass? So how are they related is density is directly proportional to mass. We read this as density is directly proportional to mass. Now coming to the volume, see, density is like this. So how do you read? Density is inversely proportional to volume. Inversely. This is directly. So there are two factors on which density depend: mass of an object and volume of the object. Now in the next segment, I'll explain to you what it means by directly proportional and inversely proportional. Density is directly proportional to mass of an object. So what does that mean? Again, take identical basket. So here we're assuming that the volume of these two baskets are same. So keeping the volume constant or same, we notice that in this first basket we have more number of balls. Here you have less number of balls, which means that this is denser than this. So more the mass, more the density. Lesser the mass, lesser the density. This is what it means by directly proportional. Density is inversely proportional to volume. So what does this mean is, now I got a bigger size basket and a smaller size basket. So in both the baskets I've put 10 balls, which means we're keeping the mass of the body as constant. So when the mass is constant, what do you notice is the 10 balls in the small basket is occupying more space compared to the 10 balls in the bigger basket. In the bigger basket, there's more empty space, in which case density is less here because the volume is greater. Density here is more because the volume is smaller. So this is what it means by density is inversely proportional to volume. Bigger the volume, lesser the density. Smaller the volume, more is the density. The next topic is called as relative density. Now look at the word relative here. What does the word relative mean here? It means that we are comparing something with something. Okay, and in the previous demonstrations we saw the density of wood, the density of oil, the density of iron nail, and then we compared, right? So that's why the word relative here means we're comparing the density of any object with the density of water. That's why it's called as relative density, all right? And the formula of relative density is, first we must know the density of a substance. In our previous example, we took wood, we took oil, we took iron nail. So density of a substance divided by density of water. So see here, we're comparing the density of a substance to the density of water, and then we concluded if the density of the substance is greater than the density of water, the substance or the object will sink, whereas if the density of the substance is lesser than the density of water, the object will float. Now we are going to see the unit for relative density. For that, we must know the density of a substance. Any substance, density we saw can be measured in gram per cubic centimeter. For now, I'm taking the CGS unit. Likewise, density of water is also measured in gram per cubic centimeter. So what you notice is gram per cubic centimeter and gram per cubic centimeter can be cancelled, which means that relative density has no unit. There's no unit for relative density, which means relative density is just the ratio. So we have a situation here now. See, an object has mass 64 gram and volume 70 cubic centimeter. Will the object float or sink in water, and why? All right. So it's similar to the question that we attempted earlier, but here we're going to do it in two ways. First, we will find the density of this object. We don't know what this object is, okay? So the formula of density is mass per unit volume. Mass is 64 gram. Volume is 70 cubic centimeter. So 64 divided by 70 will give you 0.90 gram per cubic centimeter. So this is the density of this unknown object. Now, at the back of your mind, you must remember density of water, because this object is being referred to the density of water, and density of water is equal to 1 gram per cubic centimeter. So from here, it's obvious if the density of the object is lesser than the density of water, then this object will float. There's another way to attempt this using relative density. So we saw that relative density is density of a substance divided by density of water. Density of the substance we calculated here. So let's write down 0.90 gram per cubic centimeter divided by density of water, you know, 1 gram per cubic centimeter. Gram per cubic centimeter and gram per cubic centimeter cancels. Now you have here 0.90 divided by 1 is equal to 0.90. See, does relative density have unit? No, relative density does not have unit. So what does 0.90 mean? It means that the relative density of this substance is lesser than 1. It's less than 1, which means that this object will float. So see, whether an object floats or sinks can be deduced in two ways. First, you can deduce it through density. Next, you can deduce it through relative density. And remember, if the ratio is always less than 1, that object will float. Now, what do you think will happen if the relative density of the substance is greater than 1? If the relative density is greater than 1, what do you think will happen? Yes, this substance will sink. Coming back to this prop again, if you find the density of wood divided by density of water, you will find that the ratio is lesser than 1, which means the relative density here is lesser than 1. That's the reason why the wooden block floats. If you find the density of iron nail divided by density of water, you will get the answer as relative density is greater than 1. Okay, so here the iron nail sinks in the water. Likewise, if you find the relative density of oil and water, you will see that the ratio is lesser than 1. That's the reason why the oil floats on the water. So see, students, whenever we say floating and sinking, you can, conclude in two ways. First, using the concept of density, and second, using the concept of relative density. So you have learned about density and relative density, and now we're going to see how these two concepts are related in our daily life. So have you seen this hot air balloon rising in the air? And have you also seen huge ship floating on the surface of water? So these are all due to the two concepts that we have learned. Now, as an extended work, I want you all to, search about how those hot air balloons are able to rise and how those huge ship is able to float on the water. So with that, I close my lesson. I hope you all enjoyed as much as I did from here. So thank you very much and take care of yourself.